Here's your assignment from yesterday. So I'm going to go through this. I want to make sure you're getting every problem correct. Today's assignment is very similar to this, but it gives you more practice in particularly finding the domains of these functions. Now, one of the things I want you to keep in mind is that if you have a polynomial function, for example, x cubed plus 2x squared minus 4x plus 3, its domain is always all real numbers. And all that means is that we can substitute any number in for x, and we would get a value out of this function. So any number you plug in, if you plug in a negative number, you can cube it. Fractions, you could cube. There's no problem with any of those, any number you substitute in. So we could put any value of x you can think of, any real number, and you'd get a y value out. Then the other one that we're going to see quite a bit of is square root functions. Now in a square root function, you cannot square root anything that's negative. Okay, this not only goes for square roots, it also goes for fourth root and sixth roots. Even roots of negative numbers are not possible. For example, if you had the square root of negative 4, this is not going to be a real answer because it is not made up of two of the same numbers multiplied together. Negative 4 is not 2 times 2, and negative 4 is not negative 2 times negative 2. There's no number that you can multiply times itself to get that negative 4, at least no real number. So we can't square root negatives, which means your discriminant, whatever is underneath the radical. Actually, I should call it your radicand because we aren't just talking about the quadratic formula. So radicand. The radicand, whatever's underneath that radical, if there's an x there, the radicand has always got to be greater than or equal to 0. And that just ensures you're always taking the square root or the fourth root of a positive number. So even before we attempt in problem 1 to find out, for example, what f plus g is, we can determine our domain of each of these functions. So f of x, for example, has got the square root of x, so we take what's underneath the radical x and just say you've got to be greater than or equal to 0, and we do the same thing with the other x because it's under a radical. So that's the domain for f and for g. So let's go ahead and find now the f plus g of x, and then we'll already know our domain essentially. So it just says take function f and add on function g. Now these are like radicals. They're both cube roots of, or fourth roots, thank goodness, that's a fourth root, sorry. They are both fourth roots of x's, so I've got negative 3, then I gain 15, so I'm at a positive 12 fourth root of x's. In the domain, we'll just put x has to be greater than or equal to 0. So that would be your full answer for A. For B here, we're doing a subtraction problem. So f minus g of x, we just take f of x, which is negative 3, fourth root of x, and we subtract off, just put a big minus sign there, and we subtract off the g of x, which is 15th fourth root of x. Again, they're like radicals, so we can combine those. I'm at negative 3 fourth roots of x's. I take away 15 more, so I'm at negative 18 fourth root of x. And my domain, again, x has got to be just positive numbers and 0. More specifically, generally, we say just non-negative. Non-negative includes 0. F plus g of 81. So now that we have our f plus g up here, here's what f plus g of x is. We found this in question A. It's 12 times the fourth root of x. So if we want the f plus g of 81, we replace x with 81 in the function. And now we just have to figure out what that's equal to. Well, the fourth root of 81 81 is a 3 times 3 times 3 times 3. So the 4th root of 81 is just 3. And 12 times 3 is 36. For part E here, this should have said, and I corrected it in class if you were watching, I should have asked for the F minus G of 81, just like in the first problem or in question D up here. So if I want the F minus G, I'm going to have to use the function that is F minus G right up here, that negative 18, 4th root of x. But I'm going to put in an 81. So negative 18, 4th root of 81. And so in this case, negative 18, and the 4th root of 81 is still 3. So what's that give us? Negative 54. Problem 2, now we're doing a multiplication and a division problem. So in this question A, it says find f times g. So let's do f times g of x would be, just take f of x, x squared, and say times 2 root x. Now let's simplify this. We've got an x squared times a 2 times x to the half, because x to the half is the same thing as the square root of x. We're going to rearrange this. This is all multiplication. 2 times x squared times x to the half. I can multiply a times b or b times a, so order doesn't matter when I multiply. But by bumping those x's up next to each other, I can use the law of exponents that says a to the m times a to the n is a to the m plus n. So this is like my a, it's an x and an x, okay? And it says just add the exponent, so that's 2 plus a half. Now you can, that's just 2 1/2, so that's just 5 halves. So that is what the what f times g of x is equal to. Let's work on the domain for this now. So we'll just put a comma and then we'll state what x is. And to figure out what x is, we'll look up here at the original problems. F of x, see that's an x squared, that's just a polynomial function. All real numbers. Here we've got an x under the radical, so whatever the radicand is has to be greater than or equal to 0. And when we state the domain for the overall function that we've built here by multiplying the two together, we want to use the most restrictive domain. So f of x lets you have all real numbers. G of x says no, only x is greater than or equal to 0. So this is more restrictive. It's got a smaller set. And so we're going to use that smaller one to describe our domain. So in this function, this f times g of x, we can only substitute in x's that are 0 or positive. That's all that means. So our final answer would just look like this. F over g of x, f over g of x means to take function f, x squared, and put it over function g, 2 times the square root of x. Let's see if we can simplify this a little bit. That's x squared over 2 times x to the half. Now here, because we are to have an x squared and we're dividing by x to the half, our rule is we subtract exponents. So it's going to be x to the 2, and then we have to subtract that half all over the 2 that is already down there. And let's just clean that up. 2 minus a half is 1 1/2, or 3 over 2. So x to the 3 over 2, all divided by 2, is f over g. And then lastly, our domain. Our domain is going to be the same thing again. X has to be greater than or equal to 0. Now there is one caveat we have to be careful of, and that is in our final answer. You'll notice right here when we set up this division, we actually put root x in the denominator because that's what g of x is. Well, right now we're saying it's legal to plug in 0 for x. But if you look right here, if I were to plug a 0 in for x, I'd have 2 times 0, because the square root is 0, 0. And you'd end up dividing by 0. And it's not legal to divide by 0. So we can't have 0 as an x value, and so we're going to get rid of that equal sign right there, this equal sign. And so our domain is going to be restricted to just x values that are greater than 0. And that prevents the denominator from ever being a 0. Now finally we can find the f times g of 9. And make sure we use the right function for f times g of 9. We got to come up here, and where's it at? There it is. It is 2 times x is now 9 to the 5 halves. So the 2 here means the square root the 9. So we're going to square root that 9, and that'll give us 2 times 3. Square root of 9 is 3, still to the 5th power. Let's go ahead and take 3 to the 5th power. I think that's 243. I still got the 2 out front. That's this 2 right there. And then I double everything, so I'm getting 486 if my math is correct. And then lastly, f over g of 9. We're going to go to function f over g, which is right there. It is x to the 3 halves, so it's 9 to the 3 halves all over 2. This exponent, this 2 in the denominator of the exponent means square root the 9. So square root of 9 is 3. I still have to cube it because of this 3 right there, all over 2. And 3 cubed is 27 divided by 2. So there are your solutions to the assignment from last night. You should be able to hopefully follow that well enough now to try to apply that to this second assignment over the same material. Okay, I've taken out a couple of the questions. Instead, you just have to calculate f plus g of x, find the domain, f minus g of x, find the domain, and you can see then you got a multiplication and a division, and another multiplication and division. Okay, so just 3 problems. Do the addition, subtraction, multiplication, or division, and then state the domain. I hope everybody has a great weekend. I apologize that I cannot be with everybody today for class.